So, briefly, what are neurodegenerative diseases? In its most simplest way of defining it, they are simply collections of pathologies that are characterized by decrease or decline in specific neurotransmitters that are associated with certain regions of the brain. Of course, there are diseases that are characterized by accumulation of abnormally folded proteins, that is, proteins with altered physical-chemical properties. There are diseases of multiple causative factors. Of course, we have quite a number of these neurodegenerative diseases, the likes of Alzheimer's disease, the Parkinson's disease, the Huntington's, the amyotrophic lateral sclerosis. There are very many. Now, of all these neurodegenerative diseases, Alzheimer's disease happens to be by far the most common, and it was first described by a German physician, Alois Alzheimer's, in 1901. So it was actually named after this man. Sorry, sorry, this thing is not responding. Okay, sorry. There are quite a number of hypotheses that we actually propose to explain the cause of Alzheimer's disease. We have quite a number of them, of course, but here I highlighted exactly four because this work actually focused on these four hypotheses. So there we have the cholinergic hypothesis, the oxidative stress hypothesis, amyloid hypothesis, and the tau hypothesis. Now, the cholinergic hypothesis actually explains that Alzheimer's disease is caused when there is reduction in the level of the cholinergic neurotransmitters that are associated with certain regions of the brain. And then the oxidative stress hypothesis explains that brain is highly susceptible to oxidative onslaught by free radicals. And the amyloid hypothesis explains that when amyloid, as a protein, of course, get deposited on the brain, it can also cause Alzheimer's disease. And lastly, the tau hypothesis explains that tau, as a special type of protein, also when it aggregates in form of insoluble mass and it gets deposited on the brain, it can also cause Alzheimer's disease. Now, if an individual dies of Alzheimer's disease and a kind of post-mortem examination is carried out on this person, majorly there are two major pathophysiological features that are oftentimes observed in the brain of such a person. Now, we have the beta amyloid plaques and we have the neurofibrillary tangles. So briefly, I'm going to explain what actually brings about these two pathophysiological features. Now, the picture above, the slide above shows the picture of a neuron, the nerve cells, of course, one of the cells of the central nervous system. Now, just like every other cell, the neuron has its own membrane. Now, as captured in the slide labeled here, there is a special type of protein over there that is captured as the amyloid precursor protein. Now, just as the name implies, it's the protein from which a simpler protein, which is known as the amyloid protein, the beta amyloid is, of course, biosynthesized. Now, it has been shown that when it is time for this protein to be biosynthesized, because, of course, this is a protein, and there's one thing about protein. Proteins do not live forever. At the point they get used up, they get worn out, and, of course, they become resynthesized. They become recycled, the process known as protein turnover. So when it is time for this protein to be broken down under physiological condition, it has been shown that the alpha and specifically the gamma isoform of the secretase actually hydrolyzes this protein such that simpler proteins that are of course soluble are formed. Now, because these proteins are soluble, they do not pose or cause any adverse effect. But under pathological condition, as observed in Alzheimer's disease, when this protein is to be hydrolyzed, that is when it is to be broken down, it is not broken down by the alpha or the most of the time by the beta, the gamma isoform of the secretase. Instead, it is the beta isoform of the secretase that hydrolyzes this protein. And it has been shown that when the beta isoform of the secretase hydrolyzes this protein, it leads to formation, the formation of a simpler protein, which is known as the beta amyloid protein. And of course, it has been shown that these beta amyloid proteins, they are not soluble. And because they are not soluble, they can aggregate in form of insoluble mass and get deposited between successive neurons. So one could imagine what is going to happen in the case of the slide I'm showing above. Now, that's just the picture of the beta amyloid getting deposited between successive neurons. So when it gets deposited between successive neurons, it's of course going to affect neurotransmission between this neuron and ultimately it can lead to neuronal death. Of course, the amyloid plaque formation story actually occurs extracellularly. So as this is occurring extracellularly, it triggers reactions, cascade of reactions, of course, right inside the cell that causes activation of kinase and hyperphosphorylation of the tau protein. Now the picture, the slide above shows the picture of a microtubule. Now, the microtubule as shown there is just, it should be seen as a form of pipe that facilitates the transportation of nutrients within the central nervous system. So now, we have this special type of protein, which is known as the tau protein. They are the green structures that are seen in the slide. So, the tau proteins are there to help stabilize the microtubule structure, that is to maintain the rigid structure of the microtubule. So, like I said, when amyloid plaques are formed extracellularly, it triggers reactions inside the cell that causes kinase to be hyperphosphorylated. And the result of the hyperphosphorylation that causes kinase to be activated, which in turn causes the tau protein to get hyperphosphorylated. So when these tau proteins get hyperphosphorylated, they change in shape, number one, and number two, they get dissociated from the microtubule. And like I said, they are there to help to maintain the rigid structure of this microtubule. So one could imagine what is going to happen if this tau protein get dissociated from the microtubule. As shown in the picture labeled C, you can see the tau proteins are also aggregate in form of insoluble mass, which is referred to as the neurofibrillary tangle, and then ultimately it leads to the breaking apart of the microtubule. So basically, that's the simplest way of explaining the two pathophysiological features that is observed in Alzheimer's disease. So for this work, we chose to work on editor, that's La Centella Africana, like I said, and African joint fair, because little has actually been said about their neuroprotective potential. And of course, these vegetables are widely in so many African nations, especially in the southeastern part of Nigeria. Now, there are quite a number of drugs that are actually sold over counter to help address this Alzheimer's disease. But it is quite disheartening that most of these drugs do come with serious adverse effects, and of course, none of these drugs have actually been shown to be able to completely halt the progression of this disease. So there is still need to search for an alternative therapy, which is going to be much more efficacious and less expensive, and of course, which is going to cause, not going to cause any adverse effect. So that's one of the reasons why we actually embarked on this study. And then we chose the Drosophila model because about 75% of genes that encode certain human diseases have been shown to still be conserved in Drosophila. Now, it simply implies that if there's any test compound I'm testing on this guy, if there's a way it react or act in them, that's exactly more likely going to be the same we are going to have it also in human. And simply because the use of Drosophila as an experimental model do not attract much ethical concern. So that was the reason why we actually opted him for the Drosophila model. So the aim of the experiment was to assess the neuroprotective potential of alkaloid extract from these two vegetables in fruit fly models of Alzheimer's disease. So the chemicals we used were of analytical grade and they were gotten from known sources. So like I said, we actually made use of Drosophila, which are popularly referred to as the fruit fly, as experimental model. Basically, we made use of two strains. We have the white strains, we call them the Oregons, and the transgenic strains. Now, these transgenic strains, we call them the tau flies because they are flies that have been genetically modified to overly express human tau proteins. So we made use of both strains of flies. So for the sample collection, we got our vegetables from a local market in Nigeria, and they were duly identified by hypothesis. So we followed the method described by this man, Harbon, to extract the alkaloid from this vegetable. And we carried out the following in vitro antioxidant assays, the likes of DPPH radical scavenging ability, ABTH radical scavenging ability, ferric reducing antioxidant power, lipid peroxidation assay, and hydroxyl radical scavenging ability. We also carried out methylchelating ability, and we carried out characterization of the constituent alkaloid, where we made use of the high performance lipid chromatography. So we also carried out locomotor performance assay, which was, of course, based on negative TAS6 assay. We carried out the following neurotransmitter assays: the acetylcholinesterase activity, butyrylcholinesterase activity, and the monoamine oxidase activity. Now, we carried out the following antioxidant assays. Some are enzyme-based, and the other ones are not enzyme-based. The likes of catalase, superoxide dismutase activity, and the glutathione. So the experimental grouping was such that we had 10 groups altogether that had 5 subgroups. Now, each of these 5 subgroups were made up of 40 flies of both, of course, of both genders, which were between the ages of 3 to 5 days. So, like I said, we have 10 groups altogether, as shown in the slide above. The group 1 were the set of white flies that were fed basal diet only. The group 2 were the transgenic flies fed basal diet only. On and on like that, we have the group 10, which were the transgenic flies that were fed basal diet supplemented 10 microgram per gram alkaloid extract from Netum africanum. So we had the following results. The figure 1 there shows the result for the inhibitory effect of the alkaloid extract of this vegetable on acetylcholine esterase activity in vitro in white flies. So as shown in the picture there, the 2 alkaloid extract from the vegetable were able to inhibit acetylcholine esterase activity in a dose-dependent manner. And of course, when the IC50 values of this particular assay was being deduced, we found out that the alkaloid extract from Lacetera africana actually proved more potent than its counterpart, Netum africanum. So this result in figure 2 shows that of the transgenic fly. So we also carried out locomotor performance assay, which was based on negative geotaxis. So as shown in the picture there, we have the control flies for the transgenic. They exhibited a very poor, locomotor performance. Their movements were very, very poor, which could of course be as a result of the fact that it could actually be as a result of the fact that, as a result of oxidative stress. So upon administration of this alkaloid extract, there was an improvement in the locomotor performance of these flies. So we also carried out the total tire assay. Of course, we actually had to carry out this as an indirect way of assessing antioxidant status of the biological system. It's a kind of gave account of sulfurhydride group containing compounds that are found in the biological system. So as expected, the control flies for the transgenic, more importantly, has a very poor total tire content. But upon administration of the alkaloid extract from this plant, from these 2 vegetables, there was an improvement in the total tire content. Now, the same thing also goes for the GST activity. Now, GST, which is the glutathione transferase, is of course a phase 2 detoxification enzyme that helps to, conjugate oxidative oxidants by conjugating specifically glutathione with this oxidant. So, as observed in the results and as expected, the transgenic flies also had a very poor. The transgenic fly for the control had a very poor GST activity. But upon administration of the alkaloid extract, as expected, there was an improvement in the GST activity. Now, the same thing also goes for the SOD. SOD simply is the superoxide dismutase. So it's of course an enzyme that catalyzes the dismutation of superoxide anion. So of course the hydrogen peroxide. So of course the control flies also exhibited very poor, but not too significant SOD activity. Administration of the alkaloid extract also improved the SOD activity. So we also carried out the catalase activity assay. And of course, catalase is an enzyme that facilitates the breakdown of hydrogen peroxide into water. It works in tandem with the previous enzyme I discussed, the previous enzyme which was superoxide dismutase. So we also have the same trend of results for this one also. Now, we also carried out lipid peroxidation assay, which was expressed as tauba butyric acid species content. So as expected, and of course as seen in this slide, the control flies, that is the transgenic ones, had a very high T-bus content, which is an indication of oxidative stress. Of course, an indication of oxidative stress. But upon administration of this alkaloid extract, there was a substantial, a very substantial reduction in the level of the T-bus content, especially for the set of flies that were treated with 10 microgram per gram Lacetera africana. So we also carried out the assay for the acetylcholine esterase activity, which was the in vivo assay. So as expected, the transgenic fly for the control had a very high a very high acetylcholine esterase activity. But upon administration of this alkaloid extract, there was a modulation in the activity of the acetylcholine esterase. Now we have the same trend of result for the butyrylcholine esterase activity also. So we also carried out the assay for the monoamine oxidase activity. So as expected also, the transgenic fly had a very high monoamine oxidase activity. And this can, of course, be used to explain the reason why this set of fly had a very poor locomotor performance, because it has been shown that this monoamine oxidase is, of course, an enzyme that catalyzes the breakdown of some dopaminergic neurotransmitters, for example, the dopamine. So, and of course, dopamine has been shown to be implicated in regulation of motor function. So the reason why this set of flies had a very poor locomotor performance could actually be due to the fact that they have an increased monoamine oxidase activity. So we also quantify the reactive oxygen species in general, and we express it as the hydrogen peroxide level per milligram protein. So as expected, the transgenic fly had a very high hydrogen peroxide level. So like I said earlier, we characterize the constituent alkaloid in these two vegetables using high performance liquid chromatography. So the results reveal that desulfosinidrine is the most abundant phytochemical that is found in editon. Desulfosinidrine is found majorly, is the most abundant in the alkaloid extract of editon, and atropine was revealed to be the most abundant phytochemical that is found in Netum africanum. So the findings of this result, the results reveal that alkaloid extract improve antioxidant status in both strains of flies, as revealed by their ability to increase GST, SOD catalyst activity, and of course total thiol content. And like I said, the Lacetera africana, the alkaloid extract from this Lacetera africana proved to be more potent than its counterpart, Netum africanum. So the results also reveal that the extracts from these vegetables were able to modulate cholinesterase activity, and of course were also able to modulate the monoamine oxidase activity. And of course, this result, these findings, this study also revealed that the alkaloid extract was also able to scavenge free radicals, the likes of DPPH, ADTS, and hydroxyl radicals. And of course, this result, this study also revealed that the alkaloid extract from this vegetable was also able to ameliorate lipid peroxidation. So the result also, the study also revealed that alkaloid extract from this vegetable, we had desulfosinidrine and atropine as the most abundant compound in editon and in African joint fare, respectively. So in conclusion, the result of this study demonstrates that alkaloid extract of Lacentera africana and Netum africanum possess outstanding neuroprotective potential by the ability to improve locomotor performance and modulate critical enzymes that are linked to neuronal function. Now, comparatively, alkaloid extract from Lacentera africana possess a better neuroprotective potential than its counterparts, Netum africanum, which could be adduced to the fact that it has desulfosinidrine. So further studies are recommended to assess the neuroprotective ability of this alkaloid at molecular level via gene expression. And in addition, we also recommend that co-administrations of this alkaloid be assessed to investigate possible synergistic effects of this alkaloid extract. Now, in the view of the silent drugs in future, clinical trials be done to ascertain the efficacy of this alkaloid extract in human. I'm acknowledging the following people: the Vice Chancellor of Kampala International University. I'm also acknowledging my supervisors, Professor Ganiyu Hubo, Associate Professor Adedayo Ademilui, and I'm also acknowledging Dr. Bushi Okoyemi. And lastly, I acknowledge the World Academy of Sciences, TWAS, for funding this research. Thank you so much for listening.
Thank you. Do you have questions?
My first question is about the methodology. How did you quantify the level of reactive oxygen species? It's via probe, or it's a fluorescent assay, or quantification?
Going by the protocol we follow, we express the reactive oxygen species as the level of hydrogen peroxide and standard protocol.
Okay. It's not via a probe, not a probe. It's not a fluorescent assay, no. No. You use the glucose. And how would you expect to use your plant extract for clinical trials via injection, via it will be medicines to
Yeah, as I was explaining, one of those things we really forgot to do was to carry out HPS preparation. And we found out that those procedures was including application. So in the development of drug for clinical trial, we could actually possibly play around with those active compounds.
thank you for your answer and thank you for your presentation also.
Thank you. Any other questions? Yeah, I have a question about the context of your study. You worked in the context of Alzheimer's disease, and the objective is to try to test this plant, the extract of these plants, on Alzheimer's disease. Okay. But what is the link of your experiments with Alzheimer's disease?
Yeah, of course, there's a direct link of my experiment with Alzheimer's disease because we actually acid, we experimented, we investigated critical enzymes that have direct link with Alzheimer's disease, the likes of the acetylcholine, acetylcholinesterase, butyrylcholine, and of course we also investigated the activity of the extract on monoaminoxidase also. So these are enzymes that have been implicated to play a crucial role in neuronal function.
Yeah, but your flies, they have some difficulties or some troubles with this enzyme?
Like I said, we actually worked on two strains of flies, the wild, which serve more importantly as the control flies. Then we have the transgenic ones. Now, these transgenic ones are assumed to have Alzheimer's disease because they've been bioengineered to overexpress, human tau protein, and of course, tau protein hyperphosphorylation of this tau protein have been shown to be, to be implicated also in the pathogenesis of Alzheimer's disease.
Yeah, but you didn't do some tests for memory
or okay.
Deficits of memory because you are working on Alzheimer's disease.
Yes, what we actually did to assess that, which was not recorded at this, we did this behavioral study where we did this of wine. I just feel the presentation shouldn't be too bulky, so I had to remove that one from it. Of course, we carried out that as yes, sir.
Okay. I have other questions, but it will take a lot of time. If you have other questions, yes.
Thank you for that presentation. Actually, you're saying that there was a plant that you were using uh, to do the test against the Alzheimer's disease. So, what is the phytochemical components that were in that plant that really made you to target or drive you to use the fly that you were using initially to really address the Alzheimer's disease? Because I can't really get the connection that there. Maybe you just make it clear.
I explained earlier that we carried out HPLC characterization of the alkaloid extract from these two vegetables. And of course, the reason why we do that, the reason why we do that in this experiment is to actually have an idea of the phytochemicals that are actually present in the alkaloid extract of the vegetables. And of course, we found out from my explanation here, we found out that desphosphonidrin is the most abundant phytochemical present in the alkaloid extract from Laciniella africana, while we have atropine as the most abundant phytochemical. So now, if there is any, normally the way they explain it, they say if there is any, how do I put it now, any pharmacological property of this vegetable, it could be adduced to the most abundant. It could be adduced to the most abundant phytochemical that is present in it.
So you mean it is the antioxidant?
Sorry?
It is antioxidant so it can protect against maybe much more protective, more than therapeutic.
Okay. don't know whether Dr. Gilani is here, but I would like to know if the IPR has a non-human primate model for Alzheimer's disease, whether it's natural or it is, because clearly this young man's work needs a bigger, and the Drosophila fly gives a good genetic model, but I think we need to take it to a bigger animal model to really get to figure out the benefits clearly in terms of the manifestations, the clinical manifestations for Alzheimer's disease.
Yes, we do. We have a vascular model of Alzheimer's disease that we've used. I wouldn't want to comment more on that. My colleagues have just stepped out to do that much better. That's the research group. There are some things that I might get related to that we might want to keep. That's model exists. So we did that with the Michael model, and that will be talking more about.
I think we can stop the discussion and the questions here, but I have some recommendations for all the students. If we take this example of presentation, I can say that he put a lot of text in the slides, and it was impossible for me, and I'm sure that for you it was the same. You didn't follow all the slides. You agree on that? I think this is a big problem for a majority of students. Try to put only small and short sentences in the slides and put figures and try to explain everything you put on your slides, because he put a lot of things, but he was speaking very, very quickly, and it was, for me, it's sure, I didn't follow everything he presented. And this is not only in your case, I'm sure that it's the case of many, many students, because of you have no experience, I think, with that. What is your status? You are a PhD student or postdoc or master? PhD. How many years PhD? Just started also. Mm-hmm. Okay. And you did all the work that you presented, everything, or? Oh, okay. It was a part in the master. Mm-hmm. Don't try to put only few things in your slides, the most important things. Try to be very clear for the rationale of your study. Why he chose these two plants, why he chose the model that he worked on, and try to be concise and very, very clear in the presentation of your results, please. Okay, thank you very much.
Next is Mayeso Budela. Yes.
Hello, my name is Mayeso Bedera and I'm from Malawi. So today I brought a very crude concept of what me and a colleague from Malawi are thinking of doing as the first study on Parkinson's disease in Malawi. So the topic, or the title as it stands, I think it will be changed as we discuss further. Parkinson's disease among patients attending the outpatient adult neurology clinic at Queen Elizabeth Central Hospital in Malawi. So I wanted first to give you a background of Malawi, especially its population structure. So Malawi, is a young, rapidly growing population with a strained healthcare system. So as you can see from the population pyramid, we have the majority of the population are under the age of 20 or 24. Actually, about 50% of all Malawians are under the age of 16. So the 2018 census estimated the total population to be around 17.5 million, with a median age of 17 years old and a fertility rate of 4.2 children per woman. We have free public health care, but it's very strained, one doctor for every 30,000 people. So due to the structure of our population, the essential healthcare package mainly focuses on these areas: reproductive, maternal, newborn and child health, malaria, which is a big issue, HIV/AIDS and tuberculosis, and other infectious diseases. So non-communicable diseases such as diabetes, some neurological disorders, mental disorders, they lack funding. So the rationale of this project is to collect concrete brain-like data on profiles of patients with Parkinson's disease in Malawi. So we've been thinking of the aging population because older populations, those 60 and above, are projected to make up about 8.5% of Malawi's population by 2050. So an increase of quite a large magnitude if you compare from 1987 or 1998, 2018, and then the projection to 2050. So with this projected increase in older persons, we also expect an increase in the prevalence of neurological disorders associated with aging. And at this point, there is no published data at all on Parkinson's disease and really on neurodegenerative disease in Malawi, even though these patients present at clinics. So the location would be at Queen Elizabeth Central Hospital in Blantyre, Malawi. This is the largest referral hospital in Malawi, and it is where the country's only adult neurologist is based. And there is a weekly outpatient neurology clinic that caters to patients requiring specialist consultation, mainly from the southern region of Malawi, but some are also referred to from other regions of the country. So at the neurology clinic, Parkinson's disease is diagnosed clinically using the TRAPS, or presence of tremor, rigidity, akinesia, and postural changes. For the treatment, levodopa is the prescribed treatment, but it is not available at the public health center. So this means that people have to buy the medicine, and it costs about 60 US cents for every tablet. It may sound like very little, but with this amount of money in Malawi, you can buy a full meal. So it is very expensive for the average Malawian to buy these drugs, especially considering that they have to be taken for life. So this is more like a very crude overview of the methodology. So we will need ethical clearance, and we will get it from College of Medicine's Research Ethics Committee. So this is the only research ethics committee. Well, it's one of two, but this is the main one that looks at clinical research. The study population will be the patients attending the neurology clinic at that hospital. And for starters, we want to look at the prevalence of Parkinson's disease among all the patients presenting at the clinic, look at the onset, the degrees of severity, if there are any gender differences, some family history, comorbidities, and treatment. So we thought of two ways of collecting data, and we were still discussing, and my colleague said we can get more input from this school and more advice. so that we can see which one would work best. But the first option would be using the patient's registry, going back a number of months and looking at the variables. So this would be time efficient and it would require small budget, but we may not have records of some of the variables, especially on the family history and comorbidities. The second option, which would allow us to cover all the variables, would be the use of questionnaires so recruiting patients presenting at the clinic and administering questionnaires. So get more comprehensive data. Cons, it would need adequate more time for data collection and moderately larger budget than the first option. So we want to carry out this project basically to have or to establish groundwork for a larger scale study for Parkinson's disease in Malawi. So in the long run, we would think of improving the patient care, integrating Parkinson's disease management in the essential healthcare system that at this point mainly focuses on the things I talked about, and increasing public awareness of PD for early diagnosis and reduction of stigma. It's also a similar case in Malawi where neurodegenerative diseases are accepted as the norm, as part of normal aging. So if the public are aware that it is a disorder, then some of the patients may have a chance of early diagnosis and live better lives. For the large-scale study, then we would have to look at phenotypes, genotypes, risk factors, comorbidities, and other things that I have learned so far today, which we could add onto some of the things to look at in the future of this study. So yes, that is the last slide. So thank you for your attention.
Thank you very much. Questions?
Thank you very much for your nice presentation. And I can see it is still the preliminary stage, and it is encouraging that Malawi is coming on board. It also struck me when you mentioned that the population in Malawi is increasing. That's an important thing. And then the aging population is not tiny. So because most people are below the most important age for Parkinson's disease diagnosis, what you might be considering the aspect of predominant Parkinson. Have you heard about that before? Predominant.
Early onset.
Yes. Or some signs that precede Parkinson's disease. You know, those are the things that you can also, because in your population, you can begin to catalog information about predominant Parkinson's disease at this stage. And going forward, that will make you a voice in Malawi in maybe 10 to 20 years to come from now. Because people will be referring to some of those things that you have done. And then when those people are later diagnosed with Parkinson's disease, you see, they will be referring to some work that you have done in that population that refer to. You remember when Richard Walker from the UK was talking about a woman that can smell Parkinson's disease, and he said that one of the person was not having Parkinson's disease. 6 months later, was diagnosed with Parkinson's disease. So something like that, if you can look into that, you might not have many cases of PD currently, but looking at predominant Parkinson's disease will help your research going forward.
So I forgot to put on the slides that currently there's a cohort of patients with Parkinson's disease at the clinic, and it's around 40 patients at this stage who are in the registry and who have Parkinson's disease. So it is a small population, but yeah, we can also think of the young and the early onset Parkinson's, as you said. Yeah, so thank you for that.
Other questions?
Thank you. Abu Bakr from Malaysia. Thank you. Very nice presentation. Very clear. Two questions. Number one, with regard to the supply or availability of drug from the ministry. Is there any prospect that you can push that need, to the Ministry of Health? Secondly, in your proposal, you mentioned that you learned something from today's discussion to include other parameters. I guess you want to see the social impact of the disease, right? Thank you.
Just to add something, I think it's important to add the intellectual status of the patients, because you will have a questionnaire, and all of them will not understand the questionnaire by themselves equally. The social and intellectual status. Additional question.
Okay, thank you for your presentation. I just have a question that's really itching me up. Parkinson, I just want you to tell me during maybe during diagnosis in the hospital, what do people do? Because Parkinson and Alzheimer's, they have some certain similarities that sometimes they share before maybe some differences come to pick up. So you may find, is it that one disease leads to the other, or are they actually the bigger brother or your smaller? I just want to know, because it gets to a point that Parkinson and Alzheimer, they have some certain similarities. What makes you people not do that diagnosis and confuse those two diseases? Thank you.
Okay, so I think I should have put a disclaimer. I'm not a medical doctor, so I won't be able to answer that question, but I'm sure the two diseases have very distinct diagnostic criteria. So I'm not sure about Alzheimer's, but for Parkinson's, at least in the Malawian setting, they look for the presence of the tremor, the rigidity, the kinesia, and the postural changes. With similarities to Alzheimer's, I'll need a neurologist, anyone here to help answer that. But before they do,
memory problems.
So yes, memory.
But this is not the principal problem in Parkinson's.
Yeah, memory is not the principal.
Some of the patients can develop dementia.
Yes. So I wanted to just comment on pushing the ministry for the drug availability. So I think a study like this would actually be important, because they need the numbers. They need to know the numbers of patients, so that you go to them with the evidence that the patients exist, and we really need the supply of these free drugs in the hospitals. For the intellectual status of the patients, how they may not be able to answer questions, almost all of these patients come to the clinic with their guardians. So some of the things they may not be able to answer should be covered by the carer or the guardians, which is why we should also include the carer characteristics, etc., as was presented earlier in the morning as part of the study. Yes.
I think you are missing something in the study which can be very, very important, the non-motor symptoms of Parkinson's disease, because you are focusing only on the motor symptoms. But now we know that Parkinson's patients develop many, many non-motor symptoms that can start even before the manifestation of the motor symptoms. Try to have a complete study with a lot of parameters. I totally agree with him. You have to add parameters because you will work on this study with the patients. You have the chance to have the patients try to explore the maximum of the parameters. Okay.
So do you have translation and validation of the diagnostic criteria of BE in your language?
No.
So how you can deliver to the patient? I mean, they speak English or local language like Malawi language?
So it's not direct translation, but since these are symptoms, so we do have vernacular words for the symptoms. They may not exactly mean what it says in English, but
Because for example, I mean in Egypt, for example, we have Arabic translation. I cannot say to the patient about rigidity, for example, explain rigidity. Is it cogwheel rigidity? Okay, so we have, if you need for images, website, there is a committee for translation. So they translate English to Korean, to Chinese, to Japanese, whatever. So maybe this is one option for you to start with. You can send the email to the committee. I am one of the committee in the translation in Arabic and in Arabic. So we translated in Arabic from English to Arabic. We have French, even Hebrew, Turkish, and everything.
Now he's learning Malawi.
so for the TRAP diagnostic criteria, because they are symptoms, they do have local words that are used to
Because
ask
even, I mean,
patients.
if you want to publish later on, you need this one.
Yes.
It needs to be validated from 3 or 4 persons and really to publish. This will be the problem.
Yes, it's okay. All right, thank you for that.
Any questions?
We need to go
Okay.
in
No. Thank you very much.
Thank you. I wouldn't want to dictate that we have another one. Somebody was willing to give us another one. I think we could conclude this for the day. You'll have an opportunity to present that to Samile tomorrow. This has been a very good day. We are now kind of like at an autopiloting phase. Sorry for the many hitches, but of course we expect when the opening ceremony goes with the program of the day. This normally happens. So always you want to separate the opening ceremony from the proceedings of the day because then you can gain on time. But all the same, we lost some time, gained some because of an absence of the chair of the AFC committee. But we also lost some words from him in terms of the diet's access to it. So
also driving from the hospital to here, maybe 2 cars or maybe you send the jet plane. Because I mean, there is a traffic, so maybe 45 minutes. If we use one.
well, we'll consider that. We hadn't foreseen that because for us, the reason why we were putting you closer there is because there's less traffic, if anything, none, between that place and here. So literally it will take me